In 1999, the Fields Medal-winning mathematician Terence Tao tried to build an interactive space-time diagram to visualize special relativity. He eventually had to abandon the project because the programming was too difficult. He was fighting the rigid constraints of late 90s Java architecture. The sheer overhead of writing out the syntax and managing the complex logic structures made it impossible for a single mathematician working alone. He put the project away for 27 years. Recently, Tao handed those old files over to a modern AI coding agent. It instantly ported 24 vintage Java applets into modern JavaScript. It also successfully built that impossible relativity tool, generating the entire project with only a single minor bug in a drag event. Tao observed that the bottleneck in software development has completely shifted. The high-level design decisions and mathematical logic are still up to the human. But the lower-level syntax and implementation issues have been largely automated away. Choosing a programming language no longer matters for building interactive tools. The raw ability to translate an idea into functional software code is now a cheap, readily available commodity. If generating the code itself costs almost nothing, we have to ask why organizations are spending billions of dollars to keep these AI tools running. When you type a simple prompt into an AI agent, it doesn't travel alone. Behind the scenes, the system attaches thousands of invisible data packets, tool schemas, and formatting rules to your request before the model even reads it. This chart shows the hidden orchestration overhead required just to start a task. On a single basic file reading command, Claude Code loads 33,000 background tokens. A leaner alternative like OpenCode loads only 7,000. That initial payload creates a multiplier effect. Claude Code registers 27 different background tool definitions, compared to OpenCode's 10. Each of those tools consumes tokens on every single request you make, piling up the load exponentially. The premium price covers the invisible scaffolding and context parameters used to orchestrate the intelligence. Recent findings from Microsoft Research show that this token consumption is highly stochastic. The number of tokens an agent burns on a coding task varies wildly, and it has no correlation with whether the code actually works. For an engineering team, this variance creates financial uncertainty. Running the exact same prompt through an agent can cost 30 times more at noon than it did at 11 in the morning. The primary driver of this cost is cache instability. Models frequently rewrite their cache data mid-session, and system providers charge premium rates every time those cache writes are triggered. To survive these unpredictable price spikes, the software startup Ploy had to completely rebuild their digital plumbing. They threw out their old cache architecture and shifted to workspace-scoped keys to force the model to reuse context. By strictly managing how context is stored, Ploy drove their cache hit rate up to 83.7%. That single architectural fix cut their operational costs by 27%. Engineering efficient digital plumbing is becoming a more decisive factor for success than access to the most intelligent model. All of that invisible digital token burn translates to a physical reality. Processing millions of redundant tokens takes endless server racks drawing constant power. Meta is currently building a $10 billion data center in Sturgeon County, Alberta. It is a 1 gigawatt facility designed to process this scale of artificial intelligence. Facilities like this draw so much electricity they would cripple a normal grid. Meta chose Alberta specifically because of its bring-your-own-power policy, which allows hyperscale tech companies to generate their own energy locally. To run the Sturgeon County data center, Meta is constructing a 932-megawatt natural gas plant right next to it. The capital requirements for this hardware are staggering. In the first half of 2026, investors poured $510 billion into AI startups, with 88% of that money concentrated in US-based companies. The requirement for invisible software tokens now drives hundreds of billions in capital and forces the construction of massive industrial power plants. The economic scale has grown so large that the Federal Reserve has created its first official AI task force to study the technology's macroeconomic impact. Co-led by tech billionaires and economists, the group is operating under the mandate to determine if AI acts as a disinflationary force that will keep consumer prices down. But while massive institutions prepare to govern the technology, the hacker community sees a different outcome. Programmer George Hotz argues that these multi-billion-dollar labs will never actually capture the value they are creating. Hotz points out that foundational models are essentially a very advanced autocomplete writing the general improvements of Moore's law. Because the underlying compute keeps getting cheaper, the intelligence itself will eventually be completely free. You can already see this happening. The open-source model GLM 5.2 from GPU performs at a frontier class level, and you can run it locally as a coding agent for just pennies. As the intelligence-generating code becomes a commodity, the economic value is consolidating in the physical and digital infrastructure required to orchestrate it.